How's it going, everyone? We're going super back to back. I wasn't prepared to come here already. Great. So yeah, welcome. My name is Malte. I'm the CTO of Vercel. And you've probably all seen the keynote today, this morning, or if you caught up on YouTube, probably has been in your day there. And my goal here is to make some of the things super concrete. So we talked about AI, about agents, and I want to say I'm the anti-hype guy in a very specific way, because I'm actually kind of a hypey guy. But I do hate this one phase in the kind of hype cycle of software technology where we kind of all have a little bit of FOMO. We know there's this new cool stuff, and want to build it, but we don't know what it is. And so here we are, and I want to go into agents and give you a way how to think about building agents for your own organizations. So just to get lay of the land, how many here in the room have built an agent before? Okay, I would summarize as 3 to 5% of people. So my thesis is that most of you will raise your hand in a year because it's such a transformative technology. Because it's new technology, literally every talk about agents spends like 5 minutes about defining what they are. And even better, I have 3 definitions. Let's start with Anthropic. This one's super useful. Agents are LLMs autonomously using tools in a loop. I love this definition. The other day, actually, G, our CEO, pinged me and was like, I love this definition. Great. The thing about it is, tells us what they do, like how they do it, but not what they do, right? Like, great technology, but why would I care? Google to the rescue, okay? So Google says agents are AI systems designed to perceive their environment, cool, make decisions, useful, and take autonomous actions to achieve user-defined goals. Again, seems really useful, right? Making decisions, taking actions. So agents are software that make decisions and do stuff. Great. I will contribute another definition. Actually, it's not really a definition, but I think it's helpful to say. From my point of view, agents are a new kind of software that we always wanted to write, but couldn't for economic reasons, right? They're a new kind of software. And that's how I structure it. So in my Venn diagram, which is like kind of stylized here, but I have this like really big circle, right? There's all this software that we would like to write. And there's so much software we would like to write, right? And then there's software that used to be economically viable to write, right? And it doesn't fill out all of the software that we want to write. And so now agents come to the scene, and they're adding to that circle. There's more software that we can write, and it's very valuable software. This software kind of goes through the world. It explores its problem space. It makes judgment call of how to proceed, how to move forward, and it can take action. So this is very abstractly speaking. And we were able to write software like that, but it's exactly the type of software that would lead to major spaghetti code, right? You kind of have this like notion of if this, then that, except if, all these like special cases. So what really happens as experienced software engineers, we haven't been writing a lot of this software. There isn't that much of if this, then that in the software we actually write because it's annoying, it's tedious, it's not what we want to do, right? Contrast that to the structure of an agent. The agent at the center has the LLM, and that has a bunch of tools. Remember the definition from Anthropic that an agent is really just an LLM with a range of tools that it can autonomously use. And then usually there will be some kind of trigger that sets the agent off, right? And then usually there will be some kind of output because the agent is producing something, right? Now, of course, there can be complex business rules, right? Like you can rely on the LLM to like in some emergent way know something about your business, but it probably doesn't know all the things, so you have to tell it. But you can tell it like you would tell a new employee about your business rules, about how to use the tools, because they might be complex, right? And it will do it, and it will have proper outcomes, ideally. So to make it more concrete, I want to walk through a set of agents that we've built at Vercel, and then talk about more broader use cases after. So this one is the agent that Aparna demoed this morning in the keynote, our observability agent. And let's kind of revisit the recording. So what's happening here is we are picking a time frame, and then the agent starts running, right? It takes a while because it's an LLM. LLMs, they're not the fastest kids on the block, right? And this LLM has tools for making observability queries. So right, for the first time, it kind of just sees what's going on. And then it sees a little bit, there's a little bit of signal here. So what's going on with the IP addresses? What's going on with the ASN, with the countries that these requests are being made in? The LLM is being taught that those are interesting aspects for analyzing an attack. But notably, we didn't hard code how all of these things relate to each other, right? So in the old world, this type of software was very, very difficult to write, because it could be all kinds of things. Like, why do you have an attack? Like, that's almost innumerable number of reasons, and so hard coding that in your software is, again, annoying and tedious, and so we end up, just not doing it, right? And just for completeness sake, the output in this case is to add a firewall rule to your application, but it obviously could be other things. So kind of to bring it back to the structure that I've been going through for what an agent is, right? So in the middle, we have the observability agent. That is an LLM, primarily, right? We now have two triggers. One is the manual trigger that the video was showing, but you could also imagine, for example, to use anomaly detection as the thing that sets off the agent, right? So imagine old world anomaly detection, you get paged, wake up 2 a.m. in the middle of the night, and the thing says, okay, well, actually, there was no problem, right? Isn't it better if the anomaly detection pages the agent? Agent says, actually, all seems good, right? So anyway, that could be a trigger. And then it has a couple tools, right? It can execute observability queries for the specific project on Vercel, nothing else. And it can simulate the outcome of firewall rules, which is really just a special way of doing observability queries, but because it's semantically more specific, it's really helpful to the agent. And then finally, it can make a change recommendation. Cool. So that's an agent. Again, it's really kind of interesting how well it works with relatively little coding. This is another agent. I'm not doing a product announcement here, but we were kind of working on an agent that does code review, right? Just to kind of see what can happen when you just let an agent loose on a code base, right? And this actually happens to be my code. So it's reviewing me, and it found a mistake. So I was writing a caching layer for our, I think, CMS access in our site. And I made it so that you cannot distinguish between faulty responses and not cached, which is kind of a classic mistake. I think it's really cool that it made this determination. It really nailed it. I think this is a really good comment. And let's take, once again, a look at the schema behind it, right? So once again, it's always the same pattern. In the middle, we have the LLM, the code review agent, right? In this case, it's triggered by some kind of external event, in this case, you pushing to GitHub, right? And then it has a few tools. It can diff the files. Obviously, that's what you want as a code review agent. You have a pull request, you want to know what the diff is, right? It can grab files throughout the code base. It can kind of go turn, like reading around kind of what's going on, what's the context of this code, what's not in the diff that might be relevant, right? And then finally, it produces a review comment or 0, right? What's really remarkable is how well this works with like not that much. I was actually, personally, I was very, very pessimistic about this agent. We probably have all heard about AIs being like sycophant, right? They want to please you, say, of course, sir, great, I love you. great code, right? Or like they think they're pleasing me by like making all these nits, right? And I'm not saying that's not happening, but you can actually prompt it away. You can tell it specifically kind of what degree of changes you want. And so this one is tuned to just kind of really jump in when it sees something that's wrong. We were actually literally yesterday putting the finishing touches on a new bot ID product, and I was commenting out a check because we determined that it doesn't work, I think, in the Brave browser. And then, but the way I did it kind of looked like I made it by accident, and I got a code review comment that I added a security vulnerability to my bot ID check. So again, very useful and kind of spot on, the only comment. And that's why I call this kind of the unreasonable effectiveness of agentic compute, right? Like this works better than you thought it would. If you've used Cursor, if you used Claude Code, and obviously our own tool, V0, they also all have this property, right? Where they work slightly better than you might have imagined that software would work in this day and age. So it's worth trying out. Now, let's get into the mood of thinking about what might be viable agents in our organization. They fall into several broad categories. The first one is that agents are great at research. You might have probably tried deep research as a feature in ChatGPT or Claude or any of these products, right? Now imagine you have the same capability, but you actually give it access to your own company data. So you would basically make your own ChatGPT, but you hook it, you give it tools to query company data. That would be very useful, and it would kind of have the same capability. And again, this is very easy to build. The other part are data analytics tools, right, which are, again, very useful. If you look at the Vercel agent, it's effectively an agent that does deep research, analytics access, right? It just has a tool to query the database. And what we've seen in general is that if you give a tool, kind of an agent, the tools to your existing analytics suites, that usually has pretty good outcomes. Just to categorize a little bit more, agents can run in the background or be interactive, right? The interactive ones would be what you traditionally would call a chatbot. On the other hand, background agents might email you or Slack you. So we were looking earlier at the example of our code review agent, right? That code review agent is a background agent. It gets triggered by GitHub webhook, does its job, right? And eventually, when it's done, it kind of triggers a code review comment, but it doesn't ping you any time earlier. Agents overall work really good for internal tooling, but they can also certainly be end-user facing. And we just talked about interactive ones. Those would often be the ones that you give to an end user. Now, the use case that I think is already pretty widespread is the one of support agents. Another one is the one of personalization. So traditionally, I think it would have been really difficult to build a personalization, like for example, a recommendation engine for products in your online store, right? That's something where you need like a data scientist, they do some ML research or whatever they do, I don't know, right? But now, it's at least worth trying to say, hey LLM, here's the user's history of stuff they looked at. Here's my product catalog. Do you have any recommendations what they might want to buy? Now, maybe the answer isn't good, but maybe it's great, right? And then you build an agent from it. And then finally, there is workflow automation as kind of the broad category of what agents are good at. They're good at routing information because they can make judgment call as to who or how to proceed with a process. And what's really key there is this notion of AI in the loop. Now, we've all probably heard about human in the loop, right? Like, and I'm not saying don't use that, right? Like, it feels really good that a human gets to review what the AI did. All the examples I have so far make that somewhat natural, right? But what the code review example, again, shows is that LLMs are actually amazing at giving you feedback, right? So you can imagine, not only for code review, but maybe you write a document. You have some kind of work output that you share with others, that putting in an agent in there that does a review could be really helpful. Great. So with that context of like what category of agents one might want to build, let's build one. I'm thinking about building agents in 3 phases. And phase 1 is the vibe check. And in a way, it's the most important phase. What we're doing in this phase is we're validating whether the idea we have for an agent actually has legs. And our goal is to do this validation with as minimal work as possible. And even though with, I don't know, Cursor and Cloud Code, now writing code is super cheap, we actually don't want to write any software. We're literally just going to prompt our way towards seeing if it has a chance of working. So this phase actually doesn't require any software engineering phase. In fact, the only thing you really need to know how to do is how to use ChatGPT or Claude or Gemini or any of these tools, right? The task is very simple. Try to simulate what the automated agents would do fully by hand. We're basically making the artisanal version of our agent by doing all the prompting ourselves. When the AI says, well, I need to do some more information, we're executing tools for it, right? We're kind of just doing a manual analysis, and the outcome is either, it's great or it's bad, right? So if we go through this process, we give it some CSV file of a data, maybe we give it a PDF, maybe we give it some extra information, we find out, does this agent, does it have a chance of working? Now, if the answer is no, it doesn't really work, maybe we go back and change the prompt a little bit, give it a little bit more data, right? There's a little bit of iteration happening here. But obviously, you're hoping that it seems magical, right? And what we have now is we have confidence that it's worth the investment of doing some software engineering, right? Because this thing seems to work, right? Doesn't mean that we can immediately scale it to 100,000 people, but at least there's something there. All right. So with that in our bag, let's write some code. The 2 things we're doing is essentially what I would call plain old workflow integration. You have some enterprise systems. It might be it's an enterprise event bus, Kafka, database, data warehouse. You got to hook the thing up to that thing, right? That's the code you have to write in this style. And then we're writing the agentic loop. We're going to take a look at that later, right? So it's those 2 things. One is very old school. One is a little bit new. I'm going to focus on the new part. But just to remember, we have the LLM as a trigger, output, tools. What we're going to do is we're going to build a coding agent. Who has been to Nico's workshop earlier today? Some of you. Good. Yeah, so I think he went through a more in-depth example of this. But yeah, Nico, as an example for the new version of the AI SDK, built a coding agent, similar to Cloud Code. And again, unreasonable effectiveness of agentic software, he did very little. And I'm not saying it's as good as Cloud Code, but I am saying it's incredibly good, right? So what this agent can do, it can read files, which is useful, right? It can list files, it can edit files, and it can create a PR. That's a coding agent, right? Output is just a link to PR. And so let's actually go through the specific code of the core agentic use. This is the entire implementation. I did skip the imports, right? But I use the AI SDK. We do specify a model. We pass a prompt. The prompt would be, it's a variable because the prompt is really I don't know, port my website to Tailwind, the task you give it, right? And then you give it the systems prompt. And then, finally, it does instruct the agent to do maximum 10 steps. You could do some more sophisticated condition than just a number, right? And let's read the prompt really quick so you have an idea of roughly what that looks like, right? You're a coding agent. You will be working with JavaScript and TypeScript projects. Your responses must be concise. If you make changes to the code base, be sure to run the create PR tool once you're done. So that's the entire implementation, except for the tools. Now, that's just 6 lines extra of, passing in tools. I did skip the implementation, so I'm cheating a little bit. But what do you think is the implementation of read file, right? It's fs read file sync whatever, right? This is code that's normal code, right? That you can definitely code. If you write an agent that's querying your database or your data warehouse, you use whatever API you're using, right? That's the tool implementation. It's just normal code. Awesome. So a few lines of code, and we have an agent, which has completely emergent behavior that knows how to call the tools and does something quite reasonable. So to summarize this, it should feel like writing everyday backend code with just a touch of LLM, right? So that's why you probably already know how to do it. Cool. Let's walk through how all of this looks like in the context of Vercel, right? The Vercel AI cloud landscape. So your agent on Vercel runs on fluid compute. It's probably using the AI SDK, like in the example I was showing, right? So that's really simple. Nothing new to learn, just fluid compute, just like all your functions ever did that you deployed to Vercel. And whether you use a front-end framework like Next.js or Svelte, or a backend framework like Express or Nitro, doesn't matter, right? You just deploy it to Vercel, use the AI SDK for the agent loop, and there you have it, right? Now, if you want to use a chat UI, like the chat, then you hook up what we publish as a chat SDK, right? So that's just a helpful utility, so you don't have to come up with your next version of ChatGPT from scratch. So that's helpful. If you want to have a more complex workflow, you might want to use Vercel Q. Now, that's a private beta project that we will publish in Word documentation later today. But that's really helping you to offload code and do some of these like standard backend workloads. Your agent will definitely need to talk to an LLM, and that's where the AI gateway comes in. We talked about it in our keynote. I really love it. Like, the reason I love it is on my local laptop, I can just try all of the LLMs, and I never need to worry about API keys or signing up to OpenAI, or God forbid, Gemini, right? It just works. And I can push to production, and it keeps working, which is also nice, right? But you can bring your own key, blah, 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 right? It's a useful tool. When you get scale, you can kind of load balance across multiple networks, because we're still in a kind of GPU stuff world. Right. Now, in some cases, but certainly not all cases of agents, you're generating code. There's obviously trivial cases where you actually make a coding agent and you're going to generate code, but sometimes it can actually be really helpful. Instead of saying, hey, agent, you have to, like, in your somewhat limited mind, have to come up with the answer. Sometimes it can be more productive to say, hey, agent, write a program to solve the problem I gave you, right? In these situations, you want to run some code, but that code you can't trust. Could do anything, right? And so that's where Vercel Sandbox comes in, that runs that code in a completely safe fashion. And then finally, obviously, these tools are helpful, but they're not everything you might ever need. So you bring in the Vercel marketplace. For memory, maybe you hook up Upstash. For browser use, maybe use browser base. For auth, Clerk, and so forth, right? Ingest is an incredible workflow tool that's coming soon. Might be really helpful for building agents. Cool. One word to say is that agents are chaotic compute, right? So you really need to lock your heart out. The core loop of that software was not written by you. So it does present challenges of understandability of what's going on, right? So you need to be really investing in observability. I really like this notion of a journal, right? A journal of the agent saying, here's what I did, here's what I did, here's what I did, so you can read it down. That ideally then also represents an audit log. You should probably also hook up OTel traces to give a full-on kind of hierarchical view of what's going on. And because it's just built on fluid compute, all of these things that already work, keep working. Cool. Finally, we need to optimize our agent. We now validated it works. We turn the software so that it actually works in a repeated fashion, but it might not be completely great yet. This is how I think about the broad scheme of things of whether it actually makes sense to deploy this agent, right? Like it starts out and maybe it only works for like some very specific cases. In that case, it might have negative ROI and you probably shouldn't ship it, right? But you can optimize it to become more generic handle more special cases of your business. And at some point, the ROI does become positive, right? Because this agent hopefully is relatively inexpensive to run, it doesn't have to be perfect to have positive ROI, right? In fact, I think what is being shown by the unreasonable effectiveness of agentic compute, that ROI very quickly becomes quite positive. So what are the tools that we have in our toolbox to actually do this optimization, to make it go better, right? It's really prompt engineering, right? You tell the AI about your business rules, your special cases, how to handle certain things, that it doesn't come up from scratch, right? There's a special case of that, which is prompt engineering of tools. So with tools at the AI SDK, you can describe for each tool how to use it, what the arguments mean, and the LM, again, is more like a junior employee. It has no idea how to use your tool, right? But you can tell it, and it'll figure it out. And if none of these things work, you can use AI as a judge, where you effectively you wrap your LLM with tools loop in another loop, where you say, okay, here's the output, and then use a different LLM to say, is this good? Does it fulfill my objective? And if no, go back into the original agentic loop and try a little bit harder. Then, of course, you do want to make sure that your agent stays good over time, right? That's where evals come in. These are non-deterministic systems that cannot be tested in this very strict unit testing, integration testing, etc. way, right? But evals are solving that. I don't have time today to go super in depth, but we did publish this blog post on eval-driven software development, so I do encourage reading that. One last topic is that we unfortunately need to talk about security. You've probably all seen this very, very famous XKCD about about SQL injection, right? Little Bobby tables. Parents were playing a little joke on the school. And here's the thing. SQL injection is not a solved problem. People are deploying software with SQL injection vulnerabilities every day. But if you do it right, SQL injection is a completely solved problem, right? You just escape everything, no risk. Unfortunately, that is not how prompt injection with LLMs work. Prompt injection agents is a real threat, and unlike SQL injection, there's just no robust mechanism to fix it. So does it mean agents are fundamentally insecure? It does not mean that. What it does mean is that our agent must be fundamentally secure. They must be secure even if they do get prompt injected. So for example, let's say you're using our observability agent. It must never query a different customer's data, no matter how much you prompt inject it. You effectively have to treat the prompt as untrusted. By the way, I saw some people at least smirking. The XKCD here was completely generated by ChatGPT, and I actually think it's pretty funny. Maybe it's just my humor. Cool. So what do we do, right? What are the core threats? Prompt injection, but more specifically, prompt injection from tool responses. Let's think back to our observability agent. It queries the logs of the traffic. Maybe the attacker puts something evil into the path name, right? And that might now effectively become part of the prompt, right? So we have to be aware of that and handle it. Then there's data exfiltration. The response from the agent, maybe it's markdown. If we just smash that into our website, it might, for example, include an image that goes to a third-party evil URL to then extract data. So we have to be really careful. What do? We have to strongly lock down what tool calls can do. I already mentioned, right? Never let the tool do anything that you are not happy with it doing, even if it's somewhat unattended. There is still a lot of sense in sanitizing data. Then you can use an LLM to actually supervise the other one. You can, one of the nastinesses of LLMs is you can prompt inject in Spanish, right? So all your regexes that match against English words, they won't work. But if you use an LLM, because also knows Spanish, it will be tricked and then be able to identify it, right? And you always need to treat the output of the model, Again, including Markdown, because there were at least 2 security vulnerabilities in both GitHub and GitLab that, especially to this, is very untrusted and sanitize it. Very cool. So how do we build an agent? We do the vibe check, no coding, just querying ChatGPT, Claude, Gemini. We write some code. It's just classic backend code with a sprinkle of LLM. And then we optimize it by doing prompt engineering and so forth, evals. And that's it. That's how we build an agent. Thank you very much.